In this video, we're going to be introducing the concept of a derivative and talking about the difference between average versus instantaneous rate of change. So that's what our ROC stands for here, rate of change. You've heard the phrase average rate of change before in math. That's something that comes up starting in Algebra 1. So let's talk about what that means. If we take a look at the graph of this parabola here, so we have the graph of y equals x squared. Basically, average rate of change is the slope of the secant line. The secant line is a line that crosses the curve at 2 points. The way we could find average rate of change is through the slope formula. Okay, so here I have that written for you here, that it's a slope of a secant line and can be found using the slope formula. That's your change in y over change in x. You could do it graphically too using rise over run. All right, now let's talk about instantaneous rate of change. So we're talking about at an exact moment what the rate of change is. Here's the same parabola, y equals x squared, but now you'll see that you have a line that is tangent to that curve. A tangent line only touches the curve at 1 point. The way that we could find instantaneous rate of change is through this concept of derivatives, which we're going to be talking about in the rest of this video. So it's the slope of a tangent line, and can be found by calculating the slope at the point of tangency. Okay, so that's what we're going to be looking at here, and that's basically what we are going to be calling a derivative. So the first main concept I'm introducing here in this video is that average rate of change is talking about slope of a secant line, whereas instantaneous rate of change is slope of a tangent line. But for some students, that doesn't necessarily make tons of sense yet. So here's a very loose way that you could think about it. Okay, think about how you get to school every morning. Okay, you leave your house, maybe you ride a bike, maybe you walk, maybe you drive a car. For this example, I'm going to say, let's say we take a car to work or to school every day. All right, so when you drive a car, perhaps your average rate of change over the course of your trip to school is 30 miles per hour. Does that mean that you are going 30 miles per hour at every moment throughout that trip? Definitely not, right? Sometimes maybe you had to stop at a stop sign, a red light. Maybe you're going faster than that because you were driving on the parkway. Maybe you were stuck in traffic on certain portions of the ride. So our average rate of change gives us a whole estimate of what our rate was. So we're thinking about our speed here over the course of the entire trip. Whereas instantaneous rate of change is talking about a specific moment. It's like when you're driving and you glance down at your speedometer, you can see what your speed is at that moment. Okay, that's not the average rate of change. We can think about that as our instantaneous rate of change. And there's a lot more that goes into it, and you'll learn later in this course more about velocity and speed and their differences. But that's a general idea between average rate of change versus instantaneous rate of change. When we look at average rate of change, we already know how to find slope. You've been doing it for years at this point, but we don't know how to find instantaneous rate of change, and that's what we're going to be doing here. So here's how we find the slope at the point of tangency. M, the slope, is the limit as h approaches 0 of, this is called the difference quotient. It's simply called a difference quotient because there's a subtraction sign, hence difference, and there's a division sign, hence quotient. So this is our difference quotient, and we're going to find the limit of it as h approaches 0. Basically, when we want to find a derivative or we want to calculate slope, this is what we need to do. But let's talk about what this is really doing. So what I'm going to do on this blank set of axes here is I'm going to plot 2 points. So I'm going to plot a point at x and x plus h. Okay, we're going to assume h is positive in this case, and it's greater than x. And I'm going to plot any 2 points. I'm just making this up randomly. And this y value here is going to be f of x. And this y value here is f of x plus h. Now, it doesn't really matter so much what happens in between here. You could do a variety of things to connect these 2 points. Let's say I do that. If I want to find basically the slope, and you can think about slope as average rate of change here, between these 2 points, think about slope as change in y over change in x. So I would find the slope between this point and this point. Let's say I do that. I would get f of x plus h minus f of x over the change in x values, x plus h minus x. When we do that, these x's will go away because that gives us 0. And this is how our difference quotient is formed. It's basically just the slope between 2 points. Now, when we add in this extra part about the limit as h approaches 0, what that really means is we are trying to decrease the distance between these 2 points. And if we can make that distance just about 0, we are getting a very strong estimate of an instantaneous rate of change. Think about, again, your car ride to school. If you think about your speed at the first minute and you think about your speed at the 20th minute of your car ride, when you find the slope between them, that's just giving you an overall estimate of your rate of change for that trip. But if we can find maybe the first minute and let's say the first minute and 1 second, well, we can get a really good idea of what your instantaneous rate of change is. So that's the idea of what we're doing here. And to put this all together, in this box here, it says the derivative of a function at an x value is equal to, this is called f prime of x. That's how we read that, f prime of x is equal to the limit as h approaches 0 of the difference quotient. All right, let's practice using all of this information to answer some questions. So it says, use your knowledge of rate of change to answer each question. All right, let's take a look at number 1 here. Find the average rate of change of f of x equals x cubed plus 2 over the interval negative 2, 2. Anytime you see average rate of change, this is really like an Algebra 1 question in a calculus lesson. This is just saying find the slope. Well, when you find the slope, you need 2 points, correct? You need your first point and you need your second point. When this problem is given to us, they're only giving us the x values here, right? We know the x values are negative 2 and 2. Our job is to find the y values. Think about how we do that. Well, we can plug the point into the function. And let's actually figure out what that is. So f of negative 2, that would be negative 2 cubed, so that's negative 8, plus 2 is negative 6. F of 2 cubed is 8, plus 2 is 10. So if I want to find the average rate of change, I would get 10 minus negative 6 over 2 minus negative 2. This would give me 16 over 4, or 4. So anytime, again, a problem asks for average rate of change, you're just finding the slope, but sometimes we just have to do this extra step of finding the y values before we could actually plug it into the slope formula. Number 2, find the slope of the curve f of x equals negative 2x squared at the point 1, negative 2. Notice this is not an interval. This is at an exact point at a certain instant on the graph. So when it's at a point, this is instantaneous. And the way we need to do that is by finding a derivative. And remember, our derivative is the limit as h approaches 0 of the difference quotient. So let's write down what that formula is, just so we can see it right here. And if you're confused as to what f of x plus h is, think about how we found f of 2 in the last problem. Didn't we just plug 2 into the function? That's all we'd be doing here, plugging x plus h into the function. Can that be rewritten? Absolutely. Can I rewrite this as x plus h times x plus h since we're multiplying by itself? Sure. Can I FOIL that? Multiply those two binomials. Can I distribute that negative 2? Yes, I can do all of these algebraic steps, so lots of algebra here. And that's what we're getting as f of x plus h. We're taking x plus h, plugging it into the function, and simplifying. All right, so let's find the limit as h approaches 0, and let's substitute that in. So that's what f of x plus h is. So let me just highlight that so you can see f of x plus h is all of this. So I'm just going to substitute. Now I'm going to subtract f of x, so minus negative 2x squared. That's going to change that to a positive over h. Let's simplify that here. In our numerator, I see some terms that we could cancel. And I can also divide out here, right? Do you guys see that basically negative 4xh and negative 2h squared both have an h in it? I could divide out an h. So that's going to give me negative 4x minus 2h. And now I've simplified as much as I possibly can. When we're trying to evaluate limits, remember we plug 0 in, or whatever the limit is approaching. So I'm going to plug in whatever the limit is approaching for h. So I get that this is negative 4x. Now, slope at a point should always be a numerical value, though, and we got negative 4x. So our final step, and it is a long question and takes practice, is plugging in our x value. So when I do that, I get negative 4 times 1, or negative 4, and that would be my answer. Number 3, select values of a function are in the table below. What is the best estimate of f prime of 1, or the derivative at 1? When we are estimating a derivative and we can't calculate it precisely like we did in the previous problem, we're going to use average rate of change, which is basically slope. And since we're looking to estimate at 1, we're going to strategically pick values from our table. So let's pick something to the left of 1 and something to the right of 1, and we're just going to calculate the slope. 64 minus, I'm jumping ahead here, so 64 minus 16 over 2 minus 0 gives me 48 over 2, or 24. So we can say the derivative at 1 is approximately 24. Number 4, find the derivative of f prime of x equals x squared plus 2x plus 3 when x equals negative 2. Okay, so we're going to use our limit definition of the derivative in order to calculate this. What I'm going to choose to do first is just find f of x plus h, and then I'll substitute that into that limit formula. Okay, I'm going to zoom in a bit here. X plus h squared, that's multiplying that binomial by itself. And you'll see that we do that a lot in these questions, so you might end up memorizing that x plus h squared is always x squared plus 2xh plus h squared. I'm going to distribute here, and that's what f of x plus h is. All right, now let's plug this into our limit definition of the derivative. So f of x plus h, all of that, minus f of x. I'm going to distribute that minus sign when I do that. So we're subtracting each term all over h. Let's see what we can simplify in the numerator. If you do this correctly, every term in the numerator that does not have an h should end up going away. So x squared and negative x squared, 2x and negative 2x, 3 and negative 3. Okay, all of those terms did not have an h, and they all disappeared. All right, so we are left with the limit, I'm just going to rewrite here, as h approaches 0, of 2xh plus h squared plus 2h all over h. Let's divide the h out. And then finally, let's substitute in 0 for h, and we get 2x plus 2. Since we are trying to find the derivative at x equals negative 2, we're going to plug that in for x here. So 2 times negative 2 will give us negative 4, plus 2 gives us negative 2 as our derivative. All right, one last question here. Find the slope of the line tangent to f of x equals 4x squared minus x at the point 333. Okay, basically the same exact thing. Derivative is the slope of the tangent line. So I'm going to just do the problem the same way I did the previous one. I'm going to start by finding f of x plus h. And if you prefer to do this all in one step and like write it in the limit definition, that's fine. Okay, We're going to distribute that negative across the rest. And now I'm going to distribute this 4 across this first polynomial here. All right, now that I have found f of x plus h, I'm going to put everything together with my limit definition of the derivative. So the limit is h approaches 0 of f of x plus h. I'm copying all those terms over. Minus f of x, don't forget to distribute your negative all over h. Remember, our terms without h's should go away, and I see that here. So I have the limit as h approaches 0 of 8xh plus 4h squared minus h over h. So lots of algebra work here. Divide out the h, we get 8x plus 4h minus 1. Notice that minus 1 needs to be there as a placeholder. When we evaluate 0, or h at 0, we get 8x minus 1. And we are going to take our x value, substitute it in. So we get 8 times 3 minus 1, or we get 23 as our answer.